Here show the decay, and we are asked to find the kinetic energy for this positron. Now, the first thing is that we know the energy is conserved, so we can write now mkc square equals to m pion c square plus mec square plus this ev plus k. This k is kinetic energy. We just let this k max equals k. Now this ev is just the energy of this Newtonian. So the second thing is that we can make the assumption the momentum for the uh, positron is equals to the momentum of this Newtonian. We know the E square minus the P square C square equals to M square C power 4. Right. Now, here we know this E E square equals to P square. This is a PE and C square plus the M E square C power of this 4. Now we consider the case for this Newtonian. So EV square equals to PV square and C square. Here is just 0 because the mass of this Newtonian is approximately 0. Now you can see here from this assumption this is equals to P E square C square, and this thing, that means this thing here, this term here, and this is equivalent. We can write this E square equals to E square plus the E square C power of 4. Now you can see here this EV is just equals to square root of EE square. This is minus ME square C power 4. Now we substitute this thing back to this equation here. We have C square equals to M pi C square plus MEC square plus this square root of EE square minus ME square C power 4 plus K. We rearrange minus ME minus K equals to square E square minus ME square C power 4. Now we square both sides. We get mk c square minus m pi c square minus mec square minus k, and the whole thing square here become e square minus me square c power 4. Now here you can see this is a nasty algebra here to solve, but what we can do is we can determine the value because here is the no value. This is what I'm going to do. We directly substitute the value inside here. Now this we have the mass for this is 497.65 minus is 139.57 minus is the mass of the positron. This is 0.511 and minus k the 14 square. This is equals to e square minus me square c power 4. Here, if you solve this part here, you will get this is 357 point 57 minus k square equals to e square minus me to c power 4. Now, here we know this E is a total energy, that means this is a kinetic energy plus the energy due to the mass. So C and this is the ME. This total energy is correspond to the positron. So if we square this thing, K plus MEC square this thing, we have k square plus 2 kmec square, and finally we get plus the me square c power 4. Now we substitute inside here. We substitute inside here. 3 357.57 minus k square. Here this is a k square plus 2k mec square plus me square c4 minus me square c4. So you can see this thing will just cancel out and become 0. Now we deal with this part. This part we will get 357.57 square minus 2 357.57 k and plus the k square equals to k square plus 2k, and this is the mass of the mass of this positron, which 0.511. So from here, these two will cancel out. We have the remaining this 357.57 square minus 2 357.57 k equals to 2k 0.551. Now in this case we can just solve the thing using the calculator. Okay, now we solve for this k. This is the k max. So here I get it is 178.5 MeV. This is for the answer for part A. Now how about part B? Part B, you can see this is almost the same question, just now become this guy. We want to find the maximum kinetic energy for this pion. So let's solve for this. Now the logic is completely the same. So actually we can directly take until here. Now of course the assumption we made is this momentum of this pion is equals to the momentum of the neutrino, and you go through the same process. Actually the logic is the same, so we can take until here this equation here, but the only thing we have to make different is uh this e become this E pion, and this ME become M pion. So that means 357.57 minus K squared equals to E pion square minus the M pion square power 4. Again, the logic here is the same, so actually we will get this formula after all. Just this is the we have to convert this to be the mass of the pion. So this is 2k c squared. Now here the rest is the same. Minus 2,357 k equals to 2k. Now this the mass is 139.57. So again, this time I directly solve for the k just using the calculator. So the answer is 128.6 mega electron volt. This is the answer for B. The logic here is actually the same as the A, just we have to make this NE to this pion, and this EE to this E pion. The rest is the same, the logic is the same.